Hey everyone, welcome back to our channel. If you're fascinated by the cosmos and the incredible achievements of human technology, then you're in for a treat. Today, we're diving into the latest breakthroughs from NASA's James Webb Space Telescope. Don't forget to hit that subscribe button and ring the bell so you won't miss any updates from the final frontier. The James Webb Space Telescope is transforming our view of the cosmos in unprecedented ways. From the planets of our solar system to the most distant galaxies and the most bizarre cosmic phenomena, its revelations are breathtaking. Just imagine what we're seeing includes material spiraling into a black hole. And this is just the beginning, with many more discoveries expected in the coming weeks. The creation of the James Webb Space Telescope is the culmination of decades of relentless dedication from an international team of scientists. For those of us in the field of astronomy, the arrival of JWST has been the highlight of our careers. It represents a monumental leap forward in our capabilities. Such advances are incredibly rare in science. The telescope's impact on astronomy is as significant as it is thrilling. The enormity of the James Webb Space Telescope's mirror isn't just impressive, it's transformative. This colossal mirror, significantly larger than that of its predecessor, the Hubble, enhances the telescope's sensitivity by factors of thousands. This massive leap allows us to peer deeper into the cosmos than ever before. The larger the mirror, the more light it collects, and the further into the universe we can see. What's truly astonishing, though, is the precision with which this mirror was crafted. If you were to scale the mirror to the size of the United States, the largest imperfections you would find are mere centimeters in height. This extraordinary accuracy enables James Webb to capture near-perfect images of the universe. But the capabilities of James Webb don't stop at its mirror. This telescope stands out because of its ability to detect infrared light, a type of light invisible to the human eye. The unique qualities of infrared light make it an exceptional tool for unraveling the mysteries of the universe, allowing us to observe celestial phenomena like never before. With the power of infrared light, the James Webb Space Telescope opens new doors to cosmic discovery. This remarkable capability allows astronomers like Olivia to see the atmospheres of exoplanets and detect molecules involved in star formation, such as caffeine, alcohol, and water ice, hints at the building blocks of life beyond our solar system. Infrared light, especially as captured by Webb, broadens our view beyond the visible spectrum, unveiling phenomena that were once hidden. The telescope is equipped with 3 instruments that observe in near-infrared, which is closer to what the human eye can perceive. However, it's the mid-infrared instrument, known as MIRI, that's capturing global attention. MIRI is indispensable for observing the cooler, more distant phenomena in the cosmos and delving into the earlier stages of star formation. Its impact is profound. The images MIRI produces contain unprecedented detail, allowing us to explore new wavelengths of light. Through these new wavelengths, we encounter unexpected findings, enhancing our understanding of the universe in exciting and unforeseen ways. MIRI, the mid-infrared instrument aboard the James Webb Space Telescope, is a game-changer for exploring the cosmos. It extends our reach further along the infrared spectrum, enabling us to peer through cosmic dust clouds and travel back in time more than ever before. This capability comes from understanding that as galaxies recede from us, the light they emit shifts toward the infrared spectrum. Thus, the longer the wavelengths we can detect, the further back in time we're able to see. However, MIRI almost didn't make it onto James Webb. Initially, its inclusion seemed too complex technically, and the scientific community's approach was different. But Gillian Wright, the European principal investigator for MIRI and director of the UK Astronomy Technology Centre, championed its necessity. She argued persuasively for the inclusion of a mid-infrared facility, believing it critical for the telescope's success. Her efforts paid off. When it was confirmed that MIRI would be part of the James Webb, Gillian recalls feeling elated, fully aware that it marked the beginning of a tremendously busy and rewarding phase. She was right. From the start of its construction in 2004, it took 17 years of meticulous work before the telescope was launched on Christmas Day. Jillian's vision and persistence were instrumental in equipping James Webb with this essential tool, enabling it to unlock secrets of the universe previously beyond our grasp. In 2021, the James Webb Space Telescope, with MIRI securely on board, made its thrilling ascent from the lush backdrop of a tropical rainforest, launching itself to the very brink of cosmic history. This marked the beginning of a journey back to the universe's infancy, a moment I had eagerly anticipated for years. As Christmas Day approached, my excitement mingled with nerves. The launch was set for that morning, and despite the festive spirit, my family found little joy in sharing the holiday with me, glued to the television, anxiously awaiting liftoff. I was on edge, pillows at the ready to shield my eyes should anything go awry. But the launch was flawless, a mesmerizing spectacle that transformed my nervous tension into jubilation. Watching James Webb soar into the sky was the best Christmas gift imaginable. Over the following months, the telescope journeyed more than 1.5 million kilometers away from Earth. As it settled into its new celestial perch, we gradually powered up its instruments, each step heightening the anticipation that had been building since Christmas. The late spring brought a particularly thrilling moment. MIRI was activated, signaling a new phase of discovery. The excitement of turning on each instrument was palpable. We were not just witnessing technology at work, but the unfolding of a new era in astronomy. The journey of the James Webb Space Telescope has been a blend of high excitement and nerve-wracking moments, especially knowing that after decades of meticulous preparation, something might still go wrong. When it finally became operational, the anticipation of its first images was immense. I had expected them to be extraordinary, but I was wholly unprepared for the reality of their breathtaking beauty. The first images Webb sent back were not just impressive, they were astounding in their clarity and detail. Seeing them for the first time was an emotional experience. I have been smiling ever since, overwhelmed by the perfect performance of the instruments and the stunning visuals they produced. These first glimpses into the depths of space were more than just visually spectacular. They were packed with potential discoveries. One of the early images that Webb released was of the Southern Ring Nebula, a planetary nebula marking the end of a star's life cycle. Within the MIRI image, we could discern not one, but two stars. This revelation, seeing a previously hidden red star, showcased how MIRI could enrich our understanding with new information. It confirmed details that were suspected, but never before seen with such scientific precision. In the stunning imagery of the Southern Ring, nebula revealed by the James Webb Space Telescope, we've uncovered something truly remarkable, a binary system, previously unseen. This revelation marked the first time we've observed this binary companion within the nebula, deepening our understanding of these celestial phenomena. Another captivating image presented by Webb features Stephan's Quintet, a dynamic cluster of interacting galaxies. In one particular galaxy, we can observe material being actively drawn into a black hole at its core. This process, visible in stunning detail, shows the material orbiting and spiraling into the galactic center. The level of clarity and depth we're achieving with Webb extends 13 times further than our previous capabilities in the infrared spectrum. The James Webb Space Telescope, JWST, has opened up a new window to the universe, capturing images that are not just beautiful, but are transforming our understanding of the cosmos. Launched in December 2021, JWST is designed to look further into the past than ever before, observing the first galaxies that formed after the Big Bang. Let's explore how these stunning new images are helping scientists unlock the mysteries of our universe. While Hubble has served us well for over 3 decades, JWST steps things up a notch. It operates primarily in the infrared spectrum, which allows it to peer through cosmic dust clouds and see the light from the first stars and galaxies. This capability is crucial for studying the early universe, something Hubble could only dream of. We'll discuss the technological advancements that make this possible. Each image from JWST offers more than just a pretty picture. It's a deep dive into the history of the universe. By analyzing the light from distant galaxies, astronomers can understand how galaxies and stars formed and evolved over billions of years. These insights are key to piecing together the cosmic puzzle of our origins. Why infrared? JWST's focus on this part of the spectrum is vital because it allows the observation of celestial phenomena that are otherwise hidden. Infrared can detect the thermal emissions of objects too cold or too faint for visible light, such as distant planets, nebulae, and older stars. This segment will explain the science behind infrared technology and its significance in modern astronomy. Looking forward, the James Webb Space Telescope has a busy schedule. It's set to explore everything from the atmospheres of exoplanets to the most distant observable galaxies. Each mission could redefine our understanding of the universe. Stay tuned as we cover the future missions planned for JWST and what they could mean for science. The James Webb Space Telescope is designed to capture the universe's first light, the light from the very first stars and galaxies that formed after the Big Bang. This ancient light has traveled across the cosmos for billions of years, carrying with it secrets of the early universe. By capturing this light, JWST is helping scientists piece together what the universe looked like in its infancy. Imagine being able to look back in time, almost to the very beginning of everything. That's what the JWST is doing. In this segment, we'll explore the significance of these first light observations and what they tell us about the birth of the universe. The James Webb Space Telescope is not just a scientific instrument, it's an engineering marvel. With a 21.3-foot gold-coated mirror and a sunshield the size of a tennis court, JWST is the largest space telescope ever built. Its components had to be folded to fit inside the launch vehicle and then precisely unfolded in space, a feat that required years of planning and precision engineering. In this segment, we'll delve into the complex engineering challenges that were overcome to bring this telescope to life and ensure its success in space. One of the most exciting capabilities of JWST is its ability to study the atmospheres of planets outside our solar system. By analyzing the light that passes through these atmospheres, scientists can detect the presence of water, methane, carbon dioxide, and other molecules that could indicate the potential for life. This segment will cover how JWST's instruments are designed to perform these complex observations and what we hope to learn from them. Star formation is one of the most fundamental processes in the universe, but it's also one of the hardest to study. That's because stars form in dense clouds of gas and dust that obscure visible light. JWST's infrared capabilities allow it to peer through these clouds and reveal the star nurseries where new stars are born. In this segment, we'll look at some of the stunning images JWST has captured of these hidden regions and discuss what they reveal about how stars and planetary systems come to life. The cosmic dawn refers to the period when the first stars and galaxies began to illuminate the universe. JWST is poised to study this era in unprecedented detail, shedding light on how the first structures in the universe formed and evolved. Understanding this period is crucial for piecing together the history of the universe. In this segment, we'll explore what JW evolved over time. In this segment, we'll discuss some of the most distant galaxies JWST has observed and what they tell us about the early universe. Dark matter is one of the greatest mysteries in modern astrophysics. It doesn't emit, absorb, or reflect light, making it invisible and difficult to study. However, its gravitational effects can be observed, and it plays a crucial role in the formation and evolution of galaxies. JWST's infrared instruments can peer through these clouds and reveal the detailed structures of these disks, providing insights into how planets form and evolve. In this segment, we'll discuss some of the most intriguing protoplanetary disks that JWST has observed and what they reveal about the process of planet formation. At the centers of most galaxies, including our own Milky Way, lie supermassive black holes, objects with masses millions or even billions of times that of the Sun. JWST is equipped to study these enigmatic objects in greater detail than ever before. By observing the regions around supermassive black holes, JWST can help scientists understand how these giant lives, as well as how the materials from dying stars contribute to the formation of new stars and planets. In this segment, we'll explore some of the most dramatic star life cycle events JWST has captured. The universe has been expanding since the Big Bang, and understanding this expansion is key to understanding the cosmos. JWST's observations are helping to map this expansion by studying distant galaxies and their redshifts, how much their light has stretched as the universe expands. This data is crucial for refining models of cosmic expansion and understanding the fate of the universe. In this segment, we'll discuss how JWST is contributing to our knowledge of the universe's expansion and what it might tell us about the ultimate fate of the cosmos. One of the most exciting possibilities JWST offers is the search for signs of life beyond Earth. By analyzing the atmospheres of exoplanets, JWST can detect biosignatures molecules that could indicate the presence of life. This segment will cover the science behind this search, including what kinds of biosignatures JWST is looking for and the implications of finding them. Could we be on the verge of discovering life elsewhere in the universe? JWST isn't just looking at distant galaxies, it's also turning its gaze closer to home. The telescope is observing objects in the outer solar system, including distant icy bodies and the atmospheres of planets like Uranus and Neptune. These observations are providing new insights into the composition and behavior of these remote objects. In this segment, we'll explore how JWST is enhancing our understanding of the outer solar system and what these observations could mean for our knowledge of our own planetary neighborhood. JWST's mission is expected to last for many years, with a wealth of discoveries yet to come. As the telescope continues to operate, it will tackle new challenges and answer questions we haven't even thought to ask yet. In this segment, we'll look ahead to some of the future goals and missions for JWST, from studying the first stars to exploring distant worlds. The future of space exploration is bright, and JWST is leading the way. JWST is not just a NASA project, it's a collaboration involving the European Space Agency, ESA, and the Canadian Space Agency, CSA, as well as scientists from around the world. This international effort has brought together some of the brightest minds in astronomy and engineering to create a telescope that is revolutionizing our understanding of the universe. In this segment, we'll discuss the global collaboration behind JWST and how it exemplifies the spirit of scientific cooperation across borders. Observing the distant universe is no easy task. Deep space observations require incredibly sensitive instruments, precise measurements, and the ability to filter out noise and interference. JWST's advanced technology makes it possible to overcome these challenges and capture data that would have been impossible just a few years ago. In this segment, we'll explore the challenges of deep space observations and how JWST is equipped to meet them. One of the most exciting aspects of JWST is the potential to discover the unknown. Every time we build a new, more powerful telescope, we uncover things we never expected to find. JWST is no different. It's already revealing surprises that challenge our understanding of the universe. This segment will explore some of the unexpected discoveries made by JWST and the new questions they raise. JWST's mission isn't just about scientific discovery. It's also about inspiring the public and engaging people in the wonders of the universe. The stunning images captured by JWST are shared widely, sparking curiosity and excitement about space. In this segment, we'll discuss the importance of public engagement in astronomy and how JWST is helping to inspire the next generation of scientists and explorers. As JWST continues to operate, it's already clear that its legacy will be profound. The telescope is not only expanding our knowledge of the universe, but also setting new standards for what is possible in space exploration. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.